In this video, we are going to have a short tutorial on the differences between SN1 and SN2 reaction mechanism and how they help in organic synthesis. Don't forget to like and subscribe after watching so that you can receive every update from this channel. So, SN1 and SN2 reaction both are nucleophilic substitution reaction in which one group is used to replace another group in an organic compound. But the differences in the mechanism leads to two types. The attack of the compound by the nucleophile can undergo SN1 reaction, whose mechanism differ from SN2 reaction mechanism. So here you're going to look at the differences in mechanism that exist between these two forms of nucleophilic substitution reaction. So let's first look at the SN1 substitution reaction. So in SN1 reaction, there is a formation of what you call a carbocation or a carbocation. So this reaction, it is a two-step reaction that leads to the formation of the product. There is first breaking of the bond at a different step and formation of bond at a different step. So in SN1 reaction, first there is a bond breaking at the first step, then bond formation at a different step. This one differs from the SN2 reaction. So let's look at this reaction in which bromine atom is replaced by chlorine atom to form this alkyl halide. So here, the bond between the central carbon here, this carbon, and the bromine breaks off in the first reaction to form an intermediate carbocation or carbocation. So here we have carbocation. The plus charge on the carbon means that this carbon is deficit of 2 electrons. So electron in this bonding system moves towards the bromine to assume a negative charge. Then we have an intermediate carbocation. So this step is the bond breaking step. Now in the bond formation step, the nucleophile, that's the one we are using to replace the existing living group, attacks the carbocation and we form the resulting product. So here there's first breaking of bond in one step, then formation of bond in another step. It is a two-step reaction that leads to formation of product. Bear in mind here there is always formation of carbocation in an SN1 reaction mechanism. Typical example of this reaction as seen here is halogenation of alkanes or let's say hydrocarbons to form an alkyl halide. So here you have an alkyl halide with bromine here. This bromine has been replaced by chlorine to form another alkyl halide. Here, the bromine here is what we call the living group. This bromine is the living group. Then the chlorine which comes and attacks the carbocation is the nucleophile, which we are using to substitute the bromine. That's why you call it a nucleophilic substitution reaction. Now let's look at how the mechanism for SN2 reaction goes and differ from SN1 reaction. So let's have this reaction, a reaction between a methyl bromide with a hydroxy, an alcohol, to form an alcohol and a bromine ion. So here, OH has been used to substitute the bromine in this compound to form alcohol. So the OH here is the nucleophile, which comes to substitute the bromine to form the alcohol. That's why we say it is a nucleophilic substitution reaction that releases the bromine. Here is the living group. So let's see how this reaction also differs from the SN1 reaction. Now in SN2 reaction, it is just a one-step reaction. This step is just a one-step reaction, unlike the SN1 reaction, which is a two-step reaction. Here the bond breaking and the bond formation all occur at the same time. For the SN1 reaction, you said the bond breaking and the bond formation occurs at different times. But in SN2 reaction, the bond breaking and the bond formation occurs at the same time. So here, as we've seen here, the nucleophile attacks and the attacking and the leaving all occur at the same time, unlike the SN1 reaction. So this one is just a one-step reaction that leads to formation of the product. This state is what we call transition state. Now at this state, the nucleophile bonds to the central carbon with a very weak interaction. Then the bromine also still get linked to the central carbon with a very weak interaction. Now the state where each of these can easily live is what we call the transition state. So the transition state is the state where the nucleophile or the atoms bonded to the central atom can easily live, or let's say they become quite unstable for us to form the product. Now this is just a state where there's a bond breaking and a bond formation and a bond breaking at the same time. So that's how, what do you call it? SN2 reaction occurs. Here there's just a one-step reaction that leads to formation of the product. There is a formation of a transition state in the middle. This is just a sharp reaction that occurs to give us the product, a one-step reaction and a transition state. Unlike the SN1 reaction, it is a two-step reaction with formation of carbocation as intermediate. Here we have an unstable transition state as intermediate. That's how SN1 and SN2 reaction mechanism differ from each other. So let's see this one to the same mechanism. We have bromine here replacing the chlorine, and we have the transition state here, this transition state. Then the bromine replaces the chlorine. So here the bromine becomes the nucleophile. Then we have the resulting product. So that's how SN2 and SN1 reaction mechanism occurs and differ from each other. Thanks for watching. Don't forget to subscribe to the channel so that you can receive every update from this channel. Thank you.